Welcome to the Turbit podcast. I'm Michael Tegtmeier, CEO and founder of Turbit. And today we are talking about something that doesn't always get enough attention, but is critical to turbine health, blades. With me here today are Dr. Richard Kunert, our head of data science here at Turbit, and Daniel Schingnitz, head of sales and marketing at Weidmüller Monitoring Systems. Thanks for joining, both of you. And I'm really looking forward to dive a little bit deeper how great hardware combined with state-of-the-art AI monitoring can tackle the problems of wind turbine blade health. Welcome.
Hello. Hi, Michael.
Richard, we know you already from podcasts about AI monitoring. Give us a short introduction again. Nice that you're here.
All right. Yeah. Thank you, Michael. I was indeed in the first podcast that we recorded together about the monitoring system that we've built at Turbit. And that is my main focus here at Turbit. I supervise the data science team, which makes sure that the data science models we create are trustworthy and robust and fast, and that the predictions that they generate can be used for practical purposes by our customers. My background is not in wind energy at all. My background is actually in neuroscience, but that was a long time ago. Very happy to help wind customers create value now.
Thank you, Richard. Nice that you're here again today. Daniel, give us a short intro about you. Who are you? What is Weidmüller?
Yeah, thanks, Michael. First of all, thanks for the invitation to your podcast. I'm happy to join this. My name is Daniel Schingnitz. I'm working for Weidmüller Monitoring Systems. We are a company which is producing, selling, and monitoring condition monitoring system for rotor blades of turbines. And we are on the market since 21 years already. So we are one of the pioneers in the blade-based sensor technique for health and condition monitoring. And here at Weidmüller Monitoring Systems, I am the head of sales. Since 9 years already, I'm working for this company. So hopefully I can share some ideas and informations from the last experience and also some outlook for the future with you.
Definitely some experience that we have here in the podcast. Really nice that you're here, Daniel. So maybe why does this podcast start? Many of you might have heard also this collaboration between Weidmüller Monitoring Systems and Turbit. The reason being is blades are really an integral part of the turbine, and we don't necessarily have a lot of data about blades from the first day on. But there are already sensors installed. For instance, a lot of Weidmüller ice detection sensors and other sensors in the field. And having knowledge and data about blades enables then Turbit to have much better insights about risks and failures. And especially this combination is super, super interesting for both parties. And in the long run, a better blade monitoring and integral blade monitoring makes insurances even better. And we are building together this future product. And the other thing is that putting sensors into the blades is really a hard thing. It requires a lot of experience. So we are really happy to work with a market leader here that has already installed a lot of sensors in the field and has good data quality. And lastly, for our customers who want to have an integrated solutions, it's also really, really great that at some turbines, these sensors are already installed from the first day on. And now that we have a short overview about what we're going to talk about today, let's zoom out and understand why blade health is so crucial for wind farm operations. Daniel, maybe you can start. What comes to your mind? What are the most important factors here?
I think in that case, we saw a shift in the mindset from customer perspective over the last years. So initially, customers were focusing on the ice detection only due to regulations. And due to the fact that the turbines and blades becoming bigger and bigger, we nowadays also see that the interest in a condition monitoring system raises from customer perspective. And that's caused most likely because you will have a significantly higher repair costs in case of damages on the blades. You will have longer lead times, more costs for the blade itself. So it simply makes sense for the customer and operators to monitor these. And that's something we recognized over the last 5 to 6 years, also from Weidmüller, that the customers are using the system not only for as more or less simple ice detection functionality, but also for the condition monitoring and health monitoring for the blades. So that's something we do see and recognize over the past.
So Daniel, have you seen a shift in the industry from the type of monitoring, what has been done in the past and what people are wanting to do now?
Yes. So I think in the past, everybody was using only manual inspections on yearly base to check the health of the states of the blades. Nowadays, we do see that OEMs and operators are using techniques from outside of the blade, like drone inspections on regular base. In some cases, every 3 months, for example. Others are using regular base crawler inspections inside the blade to get an idea. But it's only, from our point of view, it's only a partial look to the status of the blade. It's only a small period in time where you check the status. It's not a continuous one, where you do see a damage growth over weeks or days, something like that. That's something where we see customer interests over the last years, that they also want to monitor the growth or the status of the blade continuously. And that's something most likely driven, first of all, from the operator's perspective and owner's perspective. But nowadays, we also do see interests and issues addressed by turbine manufacturers themselves, because they are also struggling with the same issues, for sure.
Mm. Yeah, that's very interesting, because when you say continuously, maybe you can also think that if you have a drone inspection once a day, that's continuous measurement, but it's actually not, because there's so many things happening every minute in the end, every 10 minutes. And that's really what you mean when you say continuous collection of data and continuous monitoring of blades. And that enables a lot of more things that you can see. So I would add to this that now we are at the stage with this continuous monitoring, when you see the shift from the past with just manual inspections on site, like you literally go up on the turbine or hang yourself down on the blades and have a visual inspection. Now it's changing to drones, etc. And this is quite costly, these approaches. And now when you have continuous monitoring, there's even the possibility that you have other people or other third parties joining in and changing the requirements, for instance, in insurance, what you need to do on a yearly basis. Do you really need to have these visual inspections? And that's a super interesting topic that we are maybe also going to talk about later. So talking about the shift in the market, this is also what's happening right now and what technology and data can really enable. I think for everyone, it should be clear that when you have continuous data, you can move away from a reactionary state to a more preventive maintenance. I know it's a buzzword, but in this sense, I think we have actually 2 examples where you can really see that we're predicting something and we are not reacting to something with this new methods. Yeah, so we also have Richard here, our brain behind the monitoring. So let's maybe dive deeper a little bit to the technology of this quote unquote modern blade monitoring. Give us a short outline what and how we are doing this. Would be really great.
All right. Yeah, thank you. The collaboration that we started together, I think that's really important to understand, was not rushed. We really took our time to do this properly. And that meant, as a first step, to ensure that the data from the sensors that Weidmüller had already installed in wind turbines comes to us in a reliable, robust way. And that took quite some time, but we got there eventually. And now we've got a really good data connection, and everyone who has worked with data in this industry knows that this is already the first challenge that you have to overcome. And once we had the data with us, we tried to just use our standard AI monitoring approach on the data, and we quickly discovered that this is quite special data. What we're dealing with are the frequency spectra. So if you like, we've got the vibration data that we split into the different underlying frequencies. And now we can take a look at the amplitude of each frequency over time. And that kind of data is something that you typically don't see when you work with SCADA. So it required a novel approach to understand this. And we really took good time in the data science team in order to understand this better. And we took inspiration from modern natural language processing models, where the transformer models that you see in ChatGPT or in Gemini have had great success at generating language using a so-called transformer architecture. And it has, yes?
Before you continue, Richard, maybe we need to take a step back and understand what type of sensor do we have in the blades? Maybe just shortly, Daniel, what is your sensor and what are we measuring here so that we can understand maybe how we analyze it?
Yeah, maybe as an intro for Richard's analysis, blade control is using accelerometers, which are glued inside the blade. These are piezo accelerometers. A sensor box is glued at the blade length of approximately 1/3 of the blade, inside for sure. And this one is collecting into 2 directions accelerations. And based on the measured accelerations, we can then calculate the frequency or the spectra. And that's what Richard is using for evaluation. So that's the simple principle behind it.
Okay, cool. So it's like a little bit like basically a vibration sensor,
Yes.
what other people might say. And we are measuring the vibrations in flap-wise and edge-wise directions in the blade at a certain point and in a very high frequency. And this enables a little bit like a recording in sound. You have a continuous recording of the vibrations on the blades, wherever the blade is, if it's the tower on the bottom or at the top in the wind, really free. And that's an interesting thing about this type of data. Okay, sorry, Richard, to interrupt,
No,
but
nothing
I
at all.
hope this will help a little bit to understand further.
Yeah, not at all. Yeah, we are really lucky as data scientists to get good data. That's the basis of all our work. So we were really excited to see data coming from the Weidmüller system to us. And we, as I said, we took inspiration from modern natural language processing models because they're really good at the kind of frequencies and time series problems that you see in language, but also in the time series problems of turbines. It might, to the uninitiated ear, sound like a very long stretch, but actually for the data scientists in the audience, they will probably quickly realize, oh yeah, this is a cunning way to make sure we use the most modern technology here in order to create value in the wind industry. So we evaluated our approach on the data of our customers, and it had a much better simulation accuracy than what we saw with traditional deep learning models. So we are really confident that we can simulate the normal behavior of these vibrations in healthy blades. And once you know what the normal behavior of healthy blades are, you can compare it to the actual behavior of the blades and see whether they behave just like a normal healthy blade or they behave a bit differently. And if they do behave differently, that's an indication that something is wrong, that someone should take a look, that perhaps it's time for an inspection.
Okay, cool. So in other words, whenever there's something off in the blades, we generate an alarm. What is the difference to maybe a traditional monitoring system? If you look at traditional vibration monitoring, what's the difference here?
So traditional monitoring would, as far as I understand, first of all, use a much larger team that is better trained to look at the spectral information in a graphical way on some dashboard or something. And then they would be expected to see by eye whether something is behaving differently to what is expected. So for example, they might compare the 3 blades, or they might compare different turbines in the same wind park. And that's very different to what we do. What we do is that we use the historical data of the blades of a single turbine and learn the normal healthy behavior based on that, and then use that knowledge to simulate normal behavior in the current time, and then compare the current behavior to what we saw historically for the same turbine and the same blades. And if there's a discrepancy, then we believe this is worth alarming. Traditionally, this was also done in sort of, as far as I understand, in like monthly reports or something like this. And that's not what we do at all. For us, the monitoring is live. As soon as we see something unusual, the customer is alarmed.
And here comes the continuously monitoring word again. Yeah. Great. So what can you do with this? Daniel, we have made a pilot within our collaboration. Maybe you can say 1 or 2 words about this. How did it work? And yeah.
Yes, sure, Michael. Within the starting of the collaboration, we use data from roughly 30 different turbines, where we handed over the data from the sensors via the specifically developed API or interface to Turbit. And then we checked by our monitoring team, as well as by your developed algorithms, the deviations in the signals. And then most likely you were in contact with the customer in that case to evaluate what might be the root cause if we identify deviations. And I think over the last 2 to 3 years within this fleet, we identified at least 2 examples where we also received feedback from customer that there is a significant issue. Doesn't really matter if it's a blade or if it's a drivetrain or the main bearing or blade bearing. That's something which all influence the vibrational behavior of the blade. So we are able also by this kind of sensors to analyze deviations not only caused from the blade itself.
That is interesting because now you said something that is a little bit unintuitive, but weren't we talking about blade monitoring and now you're talking about drivetrain?
Yeah, because you simply can imagine that vibrational behavior of the blade is influenced by completely different external parameters. Easiest one is wind speed or temperature. So blade will react different by minus 20 degree compared with plus 30 degree or something like that. And also the operational state of the turbine affects the vibrational behavior of the blade. So it matters if which kind of power production the turbine is using or producing. And it also matters if there are deviations generated from, for example, the drivetrain, because you can see this kind of deviations in a specific frequency range also within all 3 blades. And that's something we are capable to analyze if there are deviations coming from this kind of components of the turbine. It doesn't really mean that we are replacing a drivetrain monitoring system, but we are capable to see deviations coming from the drivetrain also with the sensors inside the blades. And that's something which increases the volume or the benefit for the customer, that we are not only looking to the blades itself, but also some surroundings around the blade.
Okay, that's quite remarkable, I think, because then the scope is much higher than we maybe initially thought, right? It's not only blades, but maybe even more. Richard, from your point of view, how's the ratio between false positives and false negatives with this new approach? Is it better? Is it worse?
We have become much better. So far, our approach has been to check very carefully every alarm. So initially, we wanted to see everything that is going on the turbine, just for the development of this new system. We didn't want to miss anything. And then over time, we fine-tuned the system to be much more precise in finding only the relevant alarms that can actually make a difference to customers. So by now, I'm pretty confident that we have fine-tuned it in such a way that false alarms are kept to a minimum.
Okay, cool. It seems like we are not at the end of this collaboration. There might be much more precision or much more coverage even possible if we look into the drivetrain. And the interesting thing is that I want to add here is, why can we do this? Because we have such great data from Weidmüller. And I think that's quite unique to have this quality of data. And yeah, this really enables a lot of things in the future. From a sensors point of view, Daniel, what do you think? How will the next generation of sensors look like? What do you see? Does the industry want from the sensors?
Yeah, I think it's not really linked to the sensor itself, but the outcome for the customer. We are facing customer requests where the customer not only wants to know there's a deviation in one blade, but he also wants to know what is the criticality of the deviation or the damage, where's the position of the damage, what steps do I need to plan, like stroller inspections, collar inspections, UT scan or something like that, to identify the damage itself. And these cases or these requests were addressed to us by turbine manufacturers themselves. And that's one of the root causes why we do think a more precise damage localization inside the blade makes sense. And also maybe some other features like detecting the pitch angle of each blade makes sense. So we are very strongly believe that 2 sensor positions per blade makes sense. And also 3-dimensional MEMS sensors and gyroscopes make sense to increase the value what we can generate with the sensors. And that's something we are working on, and we will release it within the next year. So that's, I think, will also push the ability by Turbit to identify deviations coming from different root causes, not only the blade.
Yeah, that's super exciting. Richard, what is your plans on doing in the future with these kind of information, and maybe also integrating blade monitoring into other systems?
Yeah, so the nice thing from the perspective of the customer is that the workflow doesn't really change whether the information is coming through normal SCADA sensors, whatever the temperature or the power output of the turbine, or it comes from the Weidmüller system. What they have to do is they actually look at the data and perhaps take next steps if it is serious, or perhaps say better to wait a bit, depending. But the website where they do that and the visual, the graphical representation of the data is actually very similar. So they already have the option to combine the knowledge they have from SCADA cases and the knowledge they gain through Weidmüller systems in the same case on the Turbit website. And for the future, we want this sort of combination between knowledge from different sources like damage reports, service reports, SCADA documents, or Weidmüller sensor readings to not just be in the head of our customers, but to actually be done by the artificial intelligence. So this is where we want to go, that the artificial intelligence combines all this information to create a holistic view of the health of the turbine, and it can hopefully then suggest actions to take in order to increase the health and the power output of the turbine. This is where we want to go. So really combine a lot of information sources in order to recommend what to do when something is off.
Yeah, that's super exciting. Daniel, what would you say somebody who's considering and buying a monitoring solution today? I mean, we heard a lot of things. I have the feeling it's also important to get future ready, but what do you think is, or what are your arguments? What should people select when they're considering a monitoring solution for the blades?
At least customers should consider that most likely 2 times in the lifetime of a turbine, you will have a significantly damage or failure related with blades. So there will be always a payback for each system, because failures, especially for the current fleets and the current blade design and sizes, are always expensive ones. And if you can detect it in a very early stage, you can significantly reduce your repair costs. That makes sense for the customer for sure. If you don't need to replace it, even better than waiting for the crane and the new blade. So there are a lot of economic benefits for the customers using a condition monitoring system for the blades instead of leaving it as it is and waiting for some serious impacts on the blades.
Yeah, can I just second what you're saying there, Daniel? I was actually surprised when this project started. As you said, around about 30 turbines in this project, and finding damage at a turbine with a relatively small portfolio of 30 turbines seemed unlikely to me. And nonetheless, we have already found real damages on these turbines that we are monitoring. And that really speaks to me that also in the small sample that we had, it is mirroring what you say for your experience being in this industry.
That's definitely true. I mean, although I want to be devil's advocate here, and I want to say, yeah, but then I have to wait until my fleet, where I spend a lot of money to buy a lot of sensors and monitoring, etc. I have to wait until the damage is happening. And actually, that's something that our customers also said at some point. To really see the value, you sometimes need to see damage. And I want to share one other thing that's quite interesting here is we have been collaborating with insurances, especially HDI Global. And the interesting thing that opens up here is another way to think how you can insure blades. So first of all, with this continuous monitoring and with that enablement that you actually find failures before they occur, and then you can maybe prevent the damages. So you have less risk in your portfolio. Insurers can say, okay, then we have better conditions or a higher coverage, or we insure the blades at all. I think that's something you can really consider from day one. You don't even need to see a failure, but you have a benefit from the first day. And the other thing that's super exciting and interesting is with the continuous monitoring, we're adjusting the obligations, how you need to monitor your blades. And I think nowadays it's standard that you need to go, please correct me, Daniel, you need to go on site with visual inspections once a year at least. And that's costly. It's also risky for the health of the people who have to go down on the outside of the turbine. And with this continuous monitoring, there's a good chance that this is not needed any longer. And there's a different way of writing these obligations. And this is another factor that's super interesting for benefit in the first place, the moment you start using such a system.
Yes, totally agree, Michael. First of all, you can save the more or less inspection costs on service technicians, and you can, that's even more important from my perspective, you can realize a completely different risk management with the blades, event-based or pre-event based, more or less. That totally makes sense.
Yeah. Cool. I think I ran out of questions. It has been a dense but very interesting conversation with the both of you. Do you have anything that you want to add, or?
Yeah, maybe from our perspective, one sentence, why does it make sense also to cooperate with Turbit and use the information which are provided by Turbit? From Weidmüller's perspective, we are linked with the turbine, but we only receive 5 data from the turbine, which is your pitch, temperature, something like that, so that we can link deviations to the operational state of the turbine. But what Turbit in combination can do even better is linking this kind of deviation also to other SCADA data from other components of the turbine, which also supports us at the end to identify the root cause more precise. So that also from our perspective makes totally sense. As much data as is available, put into consideration, and that supports us as well.
Yeah. Yeah, it's really great also from our side to have a nice collaboration where both sides can benefit from.
Yeah, I want to highlight that too, how productive this collaboration was. I would say Weidmüller and Turbit are two quite different companies that really came together here to push the wind industry forward. And we have come together to create a totally new product that can really make a difference in the market. It was really exciting to work on this. And I'm very glad that now we're at the milestone where we have podcasts about this and real customers already receiving value from this. So it's really time now to go out and really see it for real. Yeah, it's really nice.
Great. Yeah, thanks both of you. I think that's a great point to end the podcast. Thanks for tuning in. Today we explored how advanced blade monitoring is becoming an essential component for efficient wind farm operations, and in the end, helping operators to reduce risks and maximize the lifespan of their wind turbine assets. And a special thanks to our guests, Dr. Richard Kunert and Daniel Schingnitz, for sharing your knowledge and insights and expertise. And if you're interested in learning more about how Turbit and also Weidmüller are working, you can go to the websites and please follow the podcast here. I hope this will not be the last podcast in this constellation. As we said, there are more features and more things to come in the future. And thanks for being here, both of you, and looking forward to hear you next time.
Yeah.
Oh, bye-bye.
Thanks, Michael.